Hello everyone, this is Joshua Foreman with Lab 5 Physics 2212. Let's get into it. So the purpose of this lab is to collect empirical data, whatever you want to pronounce it as, and compare it with the computational model of a bar magnet falling through aluminum foil. So what you need to know here is this law that's in French that I don't feel like pronouncing because I think I'm going to pronounce it wrong. Oh, I forgot a T in there. What do you know? There's supposed to be a T after the O. Newton's second law and Faraday's law. So the experimental result, which I definitely did for myself, was 1.26 seconds, and the computation results said 1.166 seconds, which is pretty good. It's pretty good. I'm not gonna lie, those are pretty close numbers when we're considering time. So assumptions we're gonna make is that the bar magnet is a dipole. This is helpful because there's a formula for magnetic force of a dipole. We're going to assume that air resistance is negligible and the foil is conductive because it's metal. So the experiment, I don't remember what the experiment is. Something like dropping a bar magnet into tin foil, and that's pretty much it. I assume that's the entirety of the experiment. You just drop a bar magnet in tin foil and see the time. There's no better explaining than that, so feel free to read the experiment that I designed and put into words on this slideshow. I hope you can empathize with me. So the average time was already mentioned. It was 1.26 seconds. The tube length was 0.35 meters. The width of the tube, which is like the width of the foil, is 0.6 meters. The inner radius is 0.19 meters, and the actual radius is the width plus the inner radius, because that's how math works. I'm a math major, by the way. I don't like physics. Are you still reading this? If so, you shouldn't be. Here's some code that I definitely made myself. It talks about I'm not sure what this code actually says. Okay, let's go. So here's some what ifs for this experiment. What if the resistance of the conductor were reduced to 0? That means the induced current would increase, the force would decrease, and the fall time would be longer. And if there were holes cut into the tube, that means there would be less tube, because that's how holes work. Induced current would decrease, magnetic force would decrease, magnetic fall time would be faster, because less force counteracting the gravity. Here's a little extra thing that I put at the end of my slideshow just to really drill in the point that I really need this 100. I really need this 100. I have not done well on these exams, man. These exams are killer, and I really need your support here. Your total financial and emotional support, because I need to get this scholarship back. Thank you so much for giving me 100, and have a great day.